Assalamualaikum dan hai, nama saya Muhammad Nabil bin Naina Muhammad dan nombor matrik saya 08 DEP 20F2026.
Hai, nama saya Hariwarsha Lagi Suresh. Nombor matriks 08 DEP 20F2028.
Hi, my name is Mikruben Bhupati. My matrix number is 08 DEP 20F2020. Integration is used in dealing with two essentially different types of problems. The first type are problems in which the derivative of a function or its rate of change or the slope of its graph is known and what we want to find is the function. We are therefore required to reverse the process of differentiation. This reverse process is known as anti-differentiation or finding a primitive function or finding an indefinite integral. The second problems are which involve adding up a very large number of very small quantities and then taking a limit as the size of quantities approaches zero while the number of terms tend to infinity. The process leads to the definition of the definite integral. Definite integrals are used for finding area, volume, center of gravity, moment of inertia, work done by a force, and in many other applications.
The area under a curve between 2 points can be found by doing a definite integral between the 2 points. To find the area under the curve, y will be equals to f in bracket x between x equals to a and x equals to b. Integrate y will be equal to f in bracket x between the limits of a and b. Areas under the x-axis will come out as negative, meanwhile the area above the x-axis will become positive. Now let's take a look at an example question. Here they ask what is the area between the curve y equals to x power of 2 minus 4 and the x-axis. So they have given here a graph with a shaded region. The shaded area is what we want. We can easily work out that the curve crosses the x-axis when x equals to negative 2 and x equals to 2. To find the area therefore, we integrate the function between negative 2 and 2. So in integral 2 negative 2 in bracket x power of 2 minus 4 close bracket dx equals to x power of 3 over 3 minus 4x with the integral 2 negative 2 will be equal to x over 3 negative 8 in bracket minus negative 8 over 3 plus 8 in bracket. So the answer will be 16 over 3 minus 16, which means the final answer will be negative 10.67. So this will be the area of the shaded region. So the area is negative because it is below the x-axis. Meanwhile the areas above the x-axis on the other hand gives positive results. Thank you.
Let's look at a volume of region example question. Find the volume of the solid detained by revolving the region M around the x-axis. So we are rotating this region M, which is caught between these lines and the x-axis, and we are rotating both the x-axis. So what's going to happen is we're going to take this piece and we're going to revolve it around. As you can see here, we're going to get various discs and various sizes all on top of each other. We're going to add those up, x equals to 3 to x equals to 7. So we know that that also circular disc, and if we think about it, the area of the circular disc, that's just pi r square, right? If we add all those up, we'll get the volume, and that's what integration does for us. So our general form is volume equals to the integer from x equals to a and x equals to b, because we're revolving around the horizontal y. So revolving vertically at it, we're going to make a cross. That's why we need everything in terms of x. So it will be our area in terms of x and dx. And that area is the area of one cross section. These cross sections once circles. We know the formula for that. It's pi r square. So our volume going to be from x equals to 3 to 7 because those are the boundaries. The area is pi r square and we'll figure out what r is going to be in a second. If you see closely, you can see that the radius of this disc are consistent. You can see that the radius is from the x-axis, which is in the middle. So the x-axis all the way to the blue line, which we can see, is y equals to square root of x minus 1. So that height is y, which is the square root of x minus 1. Therefore, that's our radius. So it will become an integer for 3 to 7 pi. R is going to be the square root of x minus 1 no matter where we are in terms of x squared dx. And we just going to square it because the radius is already square. So this will be the pi. Wait a minute. The pi can come out in front, the integer 3 to 7 of x minus 1. When we take the something under the square root and we square it, the square root just disappears. Dx, and now we are ready to integrate. So equals to pi into x squared over 2, that's the integer of x minus x. Evaluate from 3 to 7, which will be pi into, put the 7 in first, so 49 over 2 minus 7, plug in the 3 in 9 over 2 minus 3. Works this out. When you work this out, we will get equals to 49 over 2 minus 9 is going to be 40 over 2, and my negative 7 plus 3 is going to be negative 4. So this 20 minus 4, so it's 16 pi units cube. Don't forget the units, and it's got to be a cube because it's a volume question.
In summary, then, important points to remember from this chapter are the following: S and OP or other similarly named processes often fail to achieve integration. Integration should be thought as multiple entities behaving as if they were a single entity to achieve common organizational goals.